Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. In this video, I'll try to cover the concept of relative velocity because everything is relative in physics, in nature. So the concept of relative velocity plays a very important role in solving many problems of physics. Consider the coordinate system and origin O. Say there are 2 points or particles A and B. I have given position vectors to A and B with reference to the origin. So RA bar is defined as position of A with respect to O. So WRT stands for with respect to. And RB bar is position of B as seen from O, or position of B with respect to O. RBA bar is position of B as seen from A, or with respect to A. So this vector AB bar gives us the position of B with respect to A. Now let us apply simple triangle law of vector addition. So I would get like this. So it is R OA bar plus AB bar by triangle law would be equal to OB bar. You can see the diagram here. OA bar plus AB bar is equal to the resultant, which is OB bar, which is nothing but OA bar is RA. So because we are talking with respect to origin, I need not mention origin specifically. If I simply say RA bar, it is position of A with respect to origin, plus RBA bar, that is equal to RB bar. Then I get this equation, RBA bar is equal to RB bar minus RA bar. This is the equation which gives us the relative position. RBA bar is the relative position of B with respect to A. So RBA bar is RB bar minus RA bar. Now if you differentiate this particular equation, derivative of RBA with respect to time is equal to derivative of RB bar with respect to time minus derivative of RA bar with respect to time. Suppose the points A and B, or the particles A and B, are moving in space. So A has got certain velocity, B has got certain velocity, and velocity of A is nothing but the rate at which position of A changes as seen from origin. So VA bar is velocity of A with respect to origin. VB bar is velocity of B with respect to origin. Now if I know the velocity of A and velocity of B with respect to origin, I can easily find out the relative velocity of B with respect to A. It means B is moving and A is moving and A is observing B. As A observes B, so it is velocity of B with respect to A that tells us how A is observing B. So let us get that equation. So the equation would be, so dRBA bar by dt, which is velocity of B as seen by A, is equal to dRB by dt, that is VB bar minus VA bar. This simple equation is enough to solve any problem of relative velocity, just any problem of relative velocity. The only equation we have is this. VBA bar is VB bar minus VA bar. It is not VB minus VA. Be very clear that it is VB bar minus VA bar, the vector VB bar minus VA bar. Now from this you can find the rate of change of velocity with respect to time, that is acceleration. So of course you can also write the equation of relative acceleration to B. So I'm writing it here, acceleration of B with respect to A. By differentiating this equation, it would be acceleration of B minus acceleration of A. VBA bar is VB bar minus VA bar. That's all. This is relative velocity concept. Now, let us take one example to understand this, to understand the application of relative velocity. For example, there is a person A who is moving at the rate of 2 meters per second towards right. There is another person B, who is moving at the rate of 3 meter per second. Now, let us apply the concept of relative velocity. I know velocity of A, that is 2 I cap, because he is moving along positive x direction. And I know velocity of B, which is given to be 3 meter per second towards right. So let 3 I cap meter per second. Now when I say simply VA, it doesn't mean it is the absolute velocity of the particle or the person A. When I say A, VA, it is velocity of the particle A with respect to ground. So we don't have to always mention ground. When nothing is mentioned, when the reference point is not mentioned, we have to understand that it is with respect to ground. Now what is velocity of B as seen by A? Before doing this, let us practically observe. A is moving at the rate of 2 meter per second towards right, and B is moving at the rate of 3 meter per second towards right. If you are in place of A and observing B, don't you think B is moving away from you because the speed of B is greater than that of A? Obviously, the distance between them goes on increasing. So, if you are in place of A and observing only B, it appears as if B is going away from A. That can be understood by this simple equation. Velocity of B with respect to A is velocity of B minus velocity of A, which is 3 I cap minus 2 I cap, which is 1 I cap meter per second. A observes that, A will feel that B is moving away from him because the direction of relative velocity is towards right. So A observes that B is moving towards right at a speed of just 1 meter per second. From ground, if you observe A and B, these are the values. But if you are in place of A and observing only B, A feels that B is going away from him at the rate of 1 meter per second. That is quite obvious, right? In 1 second, say, this person will move by 3 meters and this person will move by 2 meters. So the distance of separation increased by 1 meter. So that's what this equation says. Now we can also find out the velocity of A as seen by B. B is observing A. That is simply by the concept of relative velocity VA bar minus VB bar. So what is VA bar? That is 2 I cap minus VB bar, that is 3 I cap, which is minus I cap or minus 1 I cap meter per second. So 1 is the magnitude of the relative velocity and minus I cap is the direction of the relative velocity. So B observes that. A is moving towards left because minus I cap says it is left. See, the distance between A and B is obviously increasing. A will feel that B is going away from him. Similarly, B feels that A is going away from him. So with respect to B, A going away is nothing but towards left. So B observes that A is moving towards left at the rate of 1 meter per second. So that's what this equation says, that velocity of A as observed by B. So B observes that A is moving towards left at the rate of 1 meter per second. So basically A and B observes that the other is going away with a speed of 1 meter per second. This is the concept of relative velocity. Now for example, say there are two persons A and B. Say A is moving at the rate of 1 meter per second, B is moving at the rate of 2 meter per second. Now velocity of A is 1 I cap and velocity of B is minus 2 I cap, considering the direction. So velocity of B as seen by A. Now this is obviously A and B moving towards each other, the distance between them goes on decreasing. And VB bar minus VA bar gives us minus 2 I cap minus 1 I cap, that is minus 3 I cap meter per second. Velocity of B as seen by A is observing B. So A feels that B is moving towards left, so minus I cap left. So A observing B moving towards left is nothing but A observing that B is coming towards him. B is coming towards him at the rate of 3 meter per second. Isn't it obvious? Because in 1 second A moves by 1 meter and B moves by 2 meters towards left. So the distance of separation has decreased by 3 meters. So the distance of separation is decreasing at the rate of 3 meters in 1 second. So that is the meaning of the relative velocity. Similarly, if you do VAB bar, it is VA bar minus VB bar, which is 1 I cap minus 2 I cap, 1 minus of minus 2, that is 3 I cap meter per second. VAB is velocity of A as seen by B. Velocity of A as observed by B is towards right, obviously. As observed by B, A is moving towards right, that is towards B, at the rate of 3 meter per second. This is the relative velocity of A with respect to B. So whenever you are working from a particular frame of reference, whenever you have to calculate the relative velocity or acceleration, all you should remember is this single equation, VBA bar is VB bar minus VA bar. Thank you. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.